In this lecture, we'll solve irodov problem 264. It is basically a case where cylinder is moving in a flat inclined plane with a velocity v0. Then it comes across inclination, a change in path where the inclined plane bends down by an angle alpha from the horizontal. We have to find what is the maximum velocity v0 which cylinder can have so that it rolls over. When it rolls over here, it doesn't fly off. So now let us see this problem in the stages. Let the center of mass be here just before the rolling over, and let this be the cylinder just before the rolling over. Now when it has rolled over completely, it makes 90 degree with the inclined plane now. This center of mass. Here initially it was with the flat part. Now this is the new position of the center of mass. This angle is alpha. And the new position of the cylinder is somewhat like this. When it has completely rolled over, when it has now lying on the inclined part completely. Initially it was just about to roll over. Now if you look at this angle will also be alpha between the line joining the normal and the center of mass. Now see how much center of mass has fallen. It has fallen by this distance, which will be equal to r 1 minus cos alpha, because this projection is r cos alpha and this whole is r, so the difference will be r1 minus cos alpha. What is the initial energy? Initial energy is the kinetic energy of the body, and let us take this as the reference frame. This reference from this final center of mass location. So initial energy is rotational energy mv0 square plus translational energy plus half of I omega 0 square is the rotational energy plus the potential energy at this height in reference to the new final height will be mg r1 minus cos alpha. Now since I of cylinder is mr square upon 2 and v is r omega 0, it is pure rolling, case of a pure rolling, so you will get initial energy as 1 upon 2 3 upon 2 mv0 square plus mgr 1 minus cos alpha. And what is the final energy? Final energy is equal to half 3 upon 2 mv square, where v is the velocity at this point of time when it has rolled over. There is no loss of energy. The kinetic and potential energy just get interconverted. So kinetic energy has increased effectively here. So equate these two energy. Initial energy will be equal to final energy. This is initial total energy, kinetic plus potential. So you get 3 upon 4 mv0 square plus mgr 1 minus cos alpha equal to 3 upon 4 mv square, or 3 upon 4 v0 square plus gr 1 minus cos alpha is 3 upon 4 v square. Now important condition for rolling over without jumping here is that the centrifugal force which is acting on the cylinder when it is rolling over, or when it has just rolled over, it is at this place, fully rolled over this angle alpha, because we want to take this position as the velocity will be maximum here, because it has gained the maximum velocity because of this fall in potential energy. So, and that is while rolling over, while the angle of the cylinder, just see if this is the plane, this is the inclined plane, and cylinder now rolls over. So it is rolling over here. So this motion, cylinder is basically having a circular motion. This center of mass of cylinder is having a circular motion about this point. About this point there is a circular motion of the center of mass. So the center of mass is now experiencing a centripetal force which is equal to mv square upon r. This will act on the center of mass, and center of mass is rotating at a radius a from the point of contact. That is why the centrifugal force is mv square upon r. And what is the weight is mg downwards, and if you take along this, it will be mg cos alpha. So we are now looking at the body at the inclined plane, which has just rolled over at this point of contact, and it is like this. So I am getting the components, normal component to this plane, equating that centrifugal force is upwards and mg cos alpha. For it to roll over without jumping, the centrifugal force must be less than or equal to mg cos alpha, or we can say v square, mv square upon r should be less than or equal to mg cos alpha, or v square should be less than or equal to gr cos alpha. Now put the value of v square from that equation. We will get the relationship using this relationship. Now let me put it like this. Use this relationship. We had got v square was equal to v0 square plus 4 upon 3 gr 1 minus cos alpha. This is from here we have taken, I have just multiplied by 4 upon 3, and v square should be less than or equal to gr cos alpha for rolling over without jumping. So place the value of v square here. This is the value of v square. So v0 square plus 4 upon 3 gr minus 4 upon 3 gr cos alpha should be less than or equal to gr cos alpha. So v0 square should be less than or equal to 7 upon 3 gr cos alpha minus 4 upon 3 gr. So v0 square should be less than or equal to gr upon 3 7 cos alpha minus 4. So v0 should be less than or equal to square root of gr upon 3 7 cos alpha minus 4 is your answer.